we are discussing exact differential equations, but sometimes the given equation may not be exact but can be made exact by multiplying the given equation by some suitable function of x and y so as to get the equation an exact equation. That is, a function of x and y, if we multiply the given equation by that function and if the given equation reduces to an exact differential equation, then the function we multiplied is called integrating factor. Integrating factor. Integrating factor. That is, suppose we are given a differential equation dy by dx equal to some function of x and y, or an equation of the form mdx plus n dy equal to 0. Suppose we are given a first order differential equation, may not be linear, a first order differential equation either of the form dy by dx equal to f of xy or mdx plus n dy equal to 0. Now this equation may not be exact. Now we know that the equation is exact if del m by del y equal to del n by del x. To check whether an equation is exact or not, find my, nx, and if my equal to nx, then the equation is exact. Now suppose the equation is not exact, and if we multiply some function, say function g of xy, so that gxy into mdx, g of xy into mdx plus n dy equal to 0. Now if you multiply this function by this given equation, and if the given equation reduces to an exact form, then gxy is called integrating factor. For some examples, consider x dy minus y dx equal to 0. X dy minus y dx equal to 0. Integrating factor means a function of x and y by which we multiply the given equation so as to get it as an exact equation. Now given equation is x dy minus y dx equal to 0, which is also of the form minus y dx plus x dy equal to 0. Then only m dx plus n dy. Otherwise, we write m as the x, n as minus y. Listen here, dx term first, dy term second. Therefore, minus y dx, x dy minus y dx equal to 0. We rewrite it as minus y dx plus x dy equal to 0. Of the form m dx plus n dy equal to 0. m ai del m by del y, m equal to minus y, n equal to m equal to minus y, n equal to x. My del by del y of minus y minus 1 n x del bar del x of n, that is del bar del x of x, that is equal to 1. My equal to minus 1, nx equal to 1. Therefore, my not equal to nx. Therefore, equation 1 is not exact. Given equation is not exact, therefore we have to find an integrating factor. Now by inspection, if we multiply equation 1 by 1 by x square. Multiply equation 1 by 1 by x square, we get 1 by x square into minus y dx plus x dy equal to 1 by x square into 0 equal to 0. That is minus y by x square dx plus 1 by x square into x dy, x by x square, that is 1 by x dy equal to 0. Or we can write this form y by x. Either simplify this form or we can write x by x square. X by x square dy. We can write it as minus y dx plus x dy by x square equal to 0. Reason, minus y by x square dx plus x by x square, we can write it as 1 by x, but here I write it as minus y dx plus x dy by x square only, that is equal to 0. Reason, to convert the given equation or to reduce the given equation to an exact equation. Exact equation, we know that if it is a perfect differential only, we can write it as d of some function. Therefore, check whether this is that form. There is, what about d of y by x? Now we know that d of y by x equal to, or d by dx of y by x equal to, apply quotient rule, x into dy by dx minus y into derivative x1 divided by x square, that is x dy minus y dx, that is equal to, this implies d of y by x equal to x dy minus y dx by x square. Is it clear? Now therefore this is equal to 0. Now thus, if we multiply the given differential equation x dy minus y dx equal to 0 by 1 by x square, this becomes a perfect differential. There is d of y by x equal to 0. Therefore 1 by x square, so that the equation becomes exact. Therefore 1 by x square is an integrating factor. 1 by x square is an integrating factor of the given differential equation x dy minus y dx equal to 0. Now similarly, we can prove that 1 by y square is also an integrating factor. Now given equation is x dy minus y dx equal to 0 or minus y dx plus x dy equal to 0. Multiply the given equation by 1 by y square. Therefore equation becomes 1 by y square into minus y dx plus x dy, that is minus y by y square minus x by y square dy equal to, anytime into 0 equal to 0, therefore minus y dx plus x dy by y square equal to 0, or x dy minus y dx by y square equal to 0, same as d of y by x, that is equal to 0. That becomes a perfect differential, so that the given equation x dy minus y dx becomes an exact differential equation. Hence, 1 by y square is also an integrating factor of the given differential equation. Now here therefore x dy minus y dx by y square equal to 0 can be put in the form 1 by y square 1 by y dx. ഇതിനെ മറ്റൊരു ഫോമിൽ എഴുതിയ സൊല്യൂഷൻ കാണണമെങ്കിൽ if we have to solve the equation we have to find m dx plus n dy equal to 0, mx and y if we have to verify minus 1 by y dx plus x by y square dy equal to 0. In both cases this equation reduces to the form minus 1 by y dx plus x by y square dy equal to 0, m dx plus n dy. My derivative of minus 1 by y del m by del y of minus 1 by y equal to 1 by x. We know that derivative equal to minus 1 by x square. Therefore, derivative of minus 1 by y with respect to y, that is equal to 1 by y square. Then del n by del x, del by del x of x by y square equal to 1 by y square into del by del x of x, that is equal to 1 by y square. Del n by del x is partial derivative of x by y square with respect to x, that is 1 by y square get at the constant, take it out into del by del x of x, which is equal to 1 by y square into 1 equal to 1 by y square. Del m by del y equal to del n by del x. Therefore, the given equation, this equation is exact. Solution is obtained by integrating completely with respect to x and y respectively. Integrate m completely with respect to x and integrate those terms of n which is independent of x. Here we know that n term contains x, therefore 0 dy. Here solution is integral minus 1 by y dx plus integral 0 dy equal to a constant, that is minus 1 by y into x equal to a constant, that is minus x by y equal to a constant, implies cy equal to minus x or x is equal to minus cy or x is equal to some constant c1 into y. That is the solution of x dy minus y dx. X is equal to either x is equal to c1 into y or y equal to, we can write, normally we write the form y equal to some function of x. Therefore, y equal to x by c1 or y equal to k into x, where k equal to 1 by c1. This is the solution of the equation x dy minus y dx equal to 0. Thus we get two integrating factors for the equation x dy minus y dx equal to 0. One is 1 by x square, the other one is 1 by y square. Similarly, we can show that 1 by xy is an integrating factor, 1 by x square plus y square is another integrating factor. Hope you follow me. There is integrating factor means if you are given a differential equation which is not exact but can be made exact by multiplying by a suitable function of x and y, so that the given equation becomes exact. If we are given an equation which is not exact but can be made exact by multiplying by some suitable function of x and y so that the given equation becomes exact. The term by which we multiply is called an integrating factor. Thus, we get 1 by x square, 1 by y square, 1 by xy, 1 by x square plus y square. Verify this two. 1 by xy and 1 by x square plus y square are integrating factors or not. Now thus 1 by x square is an integrating factor, 1 by y square is an integrating factor, 1 by xy is an integrating factor, and 1 by x square plus y square is also an integrating factor for the equation x dy minus y dx equal to 0. Now these whole results obtained by inspection only. Now how to find an integrating factor for a given differential equation. Integrating factor means a function of x and y by which we multiply the given equation so that the given equation becomes exact is called integrating factor. Therefore, method of finding integrating factor. Now, suppose we are given m dx plus n dy equal to 0. That is the given differential equation which is not an exact differential equation. That is here my not equal to nx. Therefore, equation 1 is not exact. Suppose 1 is not exact. M dx plus n dy equal to 0. There is 1 is not exact. If the equation is exact, then my equal to nx or del m by del y equal to del n by del x. Now this condition is not satisfied and therefore the given equation is not exact. Now to find the integrating factor for the given equation 1. Now let mu be a function so that d mu by dx equal to my minus nx by n into mu, or we can write d mu by mu equal to my minus nx divided by n into dx. Okay, the given, if we are, suppose we are having a function u of xy such that d mu by dx equal to my minus nx divided by n into mu. Now we rewrite this equation in variable separable form, that is mu term to one side and x terms to the other side. Therefore d mu by mu equal to my minus nx by n into dx. Now integrating, we get integrating d mu by mu equal to integral my minus nx by n dx. Now this becomes log mu equal to, integrate here with respect to x. Now therefore mu is the, suppose mu is the integrating factor. Now suppose this is a function, then mu equal to say capital Fx smaller. If you put it as capital Fx, then mu equal to e power fx. This is the integrating factor. Now here we write r x as the function here. If you write it as Rx, R of x, that is equal to integral of this. Let R of x equal to integral my minus nx or my minus nx by n, then let R of x equal my minus nx divided by n. Therefore, we can write log mu equal to integral R of x dx. Therefore, mu equal to e power integral R of x dx. Now, thus we get the integrating factor mu. That is, this is possible only if my minus nx by n is a function of x alone. That there exists a theorem, if my minus nx by n is a function of x alone, then the integrating factor is obtained by the formula e power integral R of x dx, where R of x equal to my minus nx divided by n. My minus nx divided by n, if it is a function of x alone, then only we can write R of x. Therefore, R of x, if it is in the form my minus nx by n, then the integrating factor mu is obtained from the formula mu equal to integrating factor mu equal to e power integral Rx dx. Similarly, if nx minus my divided by m, first we write the form my minus nx divided by n, that we write in the form R of x if it is a function of x only. Here let nx minus my divided by m if it is a function of y only, R star y. Let nx minus my by m equal to R star y, then the integrating factor mu equal to e power integral R star y dy. These are the two results to get the integrating factor for a given differential equation. Integrating factor means a function of x and y, so that if you multiply the given differential equation by this function so as to get the equation exact, that is said to be integrating factor. To get the integrating factor, method is if my minus nx, my minus nx divided by n is a function of x alone, that is right in the form Rx, then the integrating factor is obtained by the formula mu or integrating factor equal to e power integral R of x dx. But if this is not R of x not a function of x alone, then check whether nx minus my divided by m, if it is a function of y alone, a function of y alone, then integrating factor equal to e power integral R star y dy. I think it is clear. To find the integrating factor, find first mx, my, nx, examine whether they are equal. If they are equal, the given equation is exact. If they are not equal, find my minus nx by n. And if it is a function of x only, then integrating factor is e power integral of this function R of x dx. And if R of this my minus nx by n not a function of x alone, then check whether nx minus my by m. If it is a function of y only, then the integrating factor is obtained by the formula e power integral r star y dy. I think it is clear.